will probably wind up preferring to use collections in your applications because of the rich filtering, sorting, and aggregation features that are available to collections through a technology, a language called LINQ, L-I-N-Q, which stands for the Language Integrated Query. It was a very innovative feature whenever it was first introduced back a number of years ago in C# and other .NET languages. Other languages have since implemented something similar to it, but we're going to dive into that topic of LINQ and what you can do with it in the very next lesson. But first of all, let's talk about collections. We're going to talk about two collections specifically, lists and dictionaries. Now, truth be told, there's probably a dozen additional varieties of collections that you could use for very specific purposes. They each have a superpower. They each have a very specific use case where they're intended to be used. I find myself using lists and dictionaries 95% of the time, so we're going to focus on those for this lesson. But after this lesson, by all means, feel free to go off and learn all of the additional collections that are available to you and what they can do that's a little bit different than the list and the dictionary. Okay, so suppose that I have a number of cars on my car lot and I want to write an application that allows me to manage them. So I need some way to collect all of the individual instances of the car class together into a single array or collection. Now again, I might use an array of cars, but I think I'm probably going to choose to use a collection because of the added features that I'm going to gain using collections. We're going to talk about a bunch of different types of collections, but I want to start off with kind of a conversation about an older style of collection that's no longer used anymore to show why there's a newer style collection that's available, and it'll help you maybe understand that idea a little bit better. As you can see, I've got a project called Working with Collections already set up here. Please take a moment and create a new console window project. I'm also going to paste in two classes that I've defined, simplified version of the car class that we've used before, and then also I'm going to create a book class, as you can see there at the bottom. Very simple classes. And the next thing that I'm going to do is actually paste in some code to actually create new instances of each of these classes and then populate their values. So you may want to pause the video yet a third time and copy in the code that I have copied to screen there as well. All right, so the very first thing that I'm going to want to do is to work with a collection, and I'm going to work with something called an array list. And so let me just say this about array lists, that they are dynamically sized, which is one of the great benefits. You don't have to do anything to say I need to add one more item and another item and another item. Remember, with arrays, I said it was possible to resize an array, but it's a little bit of an advanced operation, not so with an array list. So that's one of the big benefits. So you can just keep adding items to it and it'll be just fine. It'll also support cool features like sorting. You can easily remove items from the collection and so on. So let's go ahead and create a new instance of this array list. And when I do, notice that we don't already have a reference or a using statement to a namespace. So what I'll have to do is hit Control period on my keyboard, and you can see that it is in a namespace called using system.collections. I'll go ahead and add that namespace to my project. And so we'll create a new one called my array list equals new array list, like so. And now that I have my array list, I can begin to add items to the array list, like, for example, the car, the first car, and then I can add a second car, like so. All right. Now, one of the problems with the old style collections like the array list is that there was no easy way to actually limit the type of data that would be stored inside of the array. So for example, I want to work with automobiles, but I might accidentally add a book into the array, and it will work just fine. All right, there's no complaints. So the old style collections are not strongly typed in so much that you can put anything inside of a collection. At first glance, that might seem great. But what if I wanted to actually then print out a list of all of the cars, makes, and models? So let me start by, at the very bottom here, type console.readline so we can get through that formality. And then I'm going to just do a for each. And what am I going to work with here? Let's just say I'm going to work for each car in my array list, all right? And then I might go console.writeLine, and let's just go car.make, like so, all right? And print that to screen, and let's run the application, and we will get an exception whenever we hit the third item in our array list. Notice that it has printed the first two to screen, but when we get to the book, it says that there's an invalid cast exception. In other words, we could not convert a car, or rather a book, which was the third item in the array list, into a car. So when we get to this spot in our, as we're iterating through each of the items in our array list, we're going to hit a problem here. And the fundamental problem is that we allowed our collection to store something other than cars. So we cannot work with these collections in a strongly typed fashion. Now what I can do, and one of the neat features here, is that I can actually remove that item prior to going into that for each list, and we should just be able to execute the application without problem. All right, so that is at least one of the good benefits there. But unfortunately, the downsides outweigh the benefits, and so let's go ahead and take a look at the newer style collections. The first I said was that we were going to look at a list, and more correctly we're going to look at something called a generic list. So often you'll see it referred to as list of T, like so, all right? And so that of T in the term generic might require a little bit of explanation. When .NET was first released, the first set of collections allow you to put anything you wanted into them, like we saw here just a moment ago. Now, it might make sense in some contexts, but typically it doesn't, and it leads to potential errors like you saw. Now, at some point then, C# introduced the notion of generics. And specifically for our purposes, they released a series of generic collections. And so a collection is essentially generic, but it requires that you make it specific by giving it the data type that should be allowed inside of that collection. So we have a generic list, but we're going to make it a specific list to cars so that we can't even add a book to that collection. So let's attempt to do this one more time. This time we're going to go list, and notice that I'm using angle brackets, and in between the angle brackets I'm going to say what data type I want to use. In this case I want to use the car data type. So list of car called myList equals new list of car, like so. And at this point, we can go ahead and add car1 just fine. We can add car list to my list. We can add car2 just fine. But what happens when we attempt to add the book into our list? Well, at the point when we attempt to add the book to the list, we get an exception. We hover over and it says it cannot convert a book to a car. All right, and that makes a little bit more sense. It is specific to a car data type, so we cannot add a book to that list. But from this point on, we can work with it now with some confidence. So each car in my list. And we can just do car.model, like so. And we would get what we would expect here. Great. A list of our car models. Okay? So that's one of the big benefits of working with a generic type, is that it allows us to work with a specific data type and only allow those types into our collection. So this is probably the most popular of all of the collections available, but I'm going to show you one additional collection called a dictionary. And a dictionary is similar to, like, think of Webster's dictionary, where you have a word and you look it up in alphabetical order and find the word that you want a definition of. And then once you find the word, you can look to its right and it will have the definition. So there is a key, which is the word itself that we want to look up, and then there is the definition next to it. So there are two components to each entry in a dictionary. There's the key and then the value itself. And so typically when you see a generic dictionary mentioned, it's going to be kind of listed like this: dictionary of T key, T value. So in this case, what we'll do is specify the data type of the key. This allows us to find one specific item by the key. Now the key should be something that is unique to every entry in the dictionary. In the case of people, there might be some identifier. It could be a customer ID in your system. It could be a social security number if you're in the United States. But something that uniquely identifies one entity inside of that dictionary. And then the value can be of any data type. In the case of, again, a customer, you might have the customer ID being the key, but the customer object itself is the value that we actually want to get access to. Now in our case, this seems a little bit weak because our car class only has make and model. And we know that we could have multiple cars that have the exact same make and model. They may have different colors, they might have been created in different years, but you can have multiple cars in the car lot that have the exact same make and model. So neither of these are good candidates for keys, but there is something called a vehicle identification number. So let's go prop string, and let's call this VIN, V-I-N, that will differentiate every car in the world that's been created. So what I'll do is come back up here to the definition, and I'm going to go car1, VIN, and I'm just going to use a very short VIN number. I think they're typically like 18 or 24 characters long or something like that. I'm not exactly sure, but this should uniquely identify every car in the world, especially every car on our car lot. So now what I can do is create a dictionary of my cars by starting off and saying something like dictionary, and then we're going to give it the two data types. The VIN will be of type string, and then the actual value will be of type car. And we're going to call this my dictionary equals new dictionary of string car. Notice that IntelliSense helped me out by essentially giving me a lot of that, and I can just hit the semicolon at the end of the line for it to type out that entire phrase. And now that I have this, what I can do is go my dictionary dot add, and we'll do car1 dot VIN and pass in car as the actual value. So the car1 VIN, again, is our key into the actual car1 itself. Okay. And likewise, we'll go add car2 dot VIN and car2. All right. And so at this point here, if I were to attempt to find a given item, so console.writeLine, and I need to find a specific car on my car lot, I can allow a user to type in the VIN number, and I can look it up in the dictionary quite easily. So say, for example, I want to do my dictionary dot, and then there's a number of different ways to go about this. I think probably one of the easiest ways, actually, let's go back and not use the dot. And here I'm actually going to use the key itself. So we'll call this B2. And then now we can reference a specific item in the dictionary of type car, so we can get the make, for example, and print that out to screen, like so. All right, we were able to find the geo that way. All right. All right. So hopefully that makes sense. Let's continue on. If you recall, when we originally were looking at, and let me comment all this out. We were looking at arrays. I said there's some interesting things you can do to initialize an array with values like we see here. Here we're creating a string of an array of strings called names, and to initialize it I give it a collection of names that are comma delimited. And so now I have an array that has 4 elements in it, and it's already been initialized with the values. You can do the same thing with the objects to initialize objects at the point of instantiation. So to do that, we'll use an object initialization syntax. In fact, let's go ahead and just to prove this all works, let's comment out everything we have up here as well. And get rid of the cars in the book. And we'll come down here and go car1 equals new car, and then notice what I do. I use that same syntax, the curly braces. And inside of here, what I can do is actually define all the values. So make equals, let's just dream large here and go make, and the model would be a 750, and we'll make it an LI, and then we'll also give it a vehicle information of C3. All right, like so. So now I've done actually 3 things in one line of code. I create a new variable called car, I create a new instance of car in the computer's memory, and now I'm getting access to that address in memory by using the car1 label, the variable name. And then I go ahead and populate the properties of the car object at the moment that I create that new instance by using this object initializer syntax. All right. Some people don't like this. It looks like it might be doing too much in one line of code, but I think you'll find that if you ever do need to hard code examples like I do frequently, that this shortened syntax actually saves you several lines of code, and it's just fine. It's valid code. All right, so let's go ahead and while we're working here, let's go ahead and create a Toyota. We'll set the model equal to a 4Runner, and we'll give that a VIN of D4. All right, like so. Okay. And so now we can work with the cars just like we did before. But in and of itself, this might not be so interesting. But this is the object initializer syntax. And we can take this one step further when it comes to working with collections. So we can use collection initializer syntax. And I want to point out one other thing, that we didn't have to use a constructor to make this work like we looked at before. That we're able to, regardless of the constructor, go ahead and set these attributes just like we use the syntax there. All right, but let's now talk about a collection initializer, which can look a little hairy, but it's essentially the same thing. We're just taking it to the next level here. So in this particular case, let's go ahead and create a list of car called myList equals a new list of car. All right. Now at this point, what I can do, and notice that I put this on separate lines here. I typically might keep this on the same line just for my own sanity here. And now inside of this new empty list of cars, I can create a series of car objects like so. In fact, what I can do at this point then is use an object initializer inside of that. So here we'll go, make equals Oldsmobile. And then we'll set the model equal to Cutlass Supreme. And then the VIN number, we'll set that equal to E5, like so, comma, and then we'll create another new car to add to this list of cars, and we'll set its object initializer, setting its make equal to Nissan, and its model equal to an Altima, and then finally its VIN will equal F6, something like that. Okay. And now what I've done all in one line of code essentially is I've created a collection and I've added 2 objects, and in each of those objects I went ahead and already initialized all of their property values. All right. Whew. So there's a lot going on there in just that one line of code. Great. So at any rate, just wanted to recap the things that we talked about in this lesson. First of all, we talked about the difference between arrays and collections, and I promised that there will be a more obvious set of features that are available to collections, which we'll learn about in the next video. We talked about the old style collections versus the new generic collections, and we said generic collections are superior because they allow us to make sure that we're only adding types, specific types to our collection. So we make a generic collection specific by passing in the data type that should be allowed to be referenced inside of that collection. Okay. Then we looked at object initializers, just a shorthand syntax for initializing the properties of a new instance of an object. And then finally taking that one step further within a collection initializer, where not only are we creating a new collection, but then initializing it with new instances of the car collection. In both of those cases, then we are using object initializers. So we can do it all on one line of code. Now, honestly, unless you're building a lot of example code like I do, you may not see this as often unless you are creating some hard-coded objects for use within your application. But I wanted you to be aware of that syntax nonetheless, because we're going to use it again in the next lesson. And we'll see you there. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this lesson, we're going to look at LINQ, the language integrated query syntax that was introduced some years ago to provide a way to filter, sort, and perform other aggregate operations on collections of our data types. And so we'll demonstrate two different styles of LINQ syntax. There's a query syntax that will resemble the structured query language SQL for querying databases. So if you're already familiar with SQL, this will at least feel familiar. Then there's also a method syntax, which might feel more familiar to C# developers. However, there is one little strange nomenclature thingy that we got to figure out, okay? But I think it's pretty easy. I think I have a good way of explaining it to you, and hopefully you'll understand what it's trying to do there. But what I'd recommend is you find the code for this lesson. There should be a before and after folder, and you want to copy the code in the before folder into your projects directory, and then open it up, and you'll be where I'm at right now in the Understanding LINQ project. You can see that I merely created a car class, and then I also have here a collection initialized class filled with cars, filled with attributes that we'll be able to search and sort on, and that'll give us something to work with here. All right, so what I want to do to begin with is to kind of show you a comparison between LINQ's query syntax and then LINQ's method syntax to do the exact same thing. And you'll see the obvious difference, and we'll talk about the ways in which they're different. But let's begin with a query where we want to find all BMWs in this list of cars called My Cars. So it's as easy as this, and we'll talk about the var keyword here in just a moment. But BMWs equals from car in cars, whoops, from car in My Cars, where car.make is equal to BMW select car. All right. And so now let's come down here and print all those guys out. So let's go console.write line. And let's provide the vehicle information number. So let's do 0 and 1. So we'll go, actually, let's do this. Let's go for each, tab, var car in BMWs, console.write line, and then we'll go car.model and car.vin. All right, and let's go ahead and add some of our replacement characters in there. All right, now let's go ahead and run the application. And we see that we get 3 cars that have been returned. So of all of the cars, I think there's 5 or 6, 3 of them with those VINs, A1, C3, and E5 are BMWs. And if you take a look at the data, that would be correct. So very quick, concise way of finding only those cars that match that criteria. All right, what if we wanted to add additional criteria? So say, for example, we wanted to also see where the car's year equals 2010. We could do that and rerun the application, and now we see that it just finds one of the BMWs was created in 2010. It is this last one, the 555i. All right. So that is the language integrated query syntax, the query syntax of LINQ. Let's go ahead and comment that out and compare that to the method syntax. And so here we'll go var BMWs equals mycars dot where. All right, so this will give us all the BMWs. So let's go ahead and run that. And it gives us the same 3 that we got before. Now what if we wanted to also find only those where the year is equal to 2010? Then we would do that. Okay, and so you can see we found just that E5, that last one. All right, so this might take a little explanation here. For the moment, let's just ignore this last part. We'll talk about that in a moment. But what you see here, in fact, the whole thing in between the opening and closing parentheses is called a lambda expression. And you can think of it as a mini method. Essentially, what will happen is you say given P, so given an instance of the collection, only return back to me those instances of car where the make is equal to BMW. See how easy that is? Again, just a mini method. You can kind of think of this as like the input parameter, and then this is just some condition, and when it's true, then return that instance and add it into this little collection over here. So now that we have a subset of all of the available cars on our car lot. Furthermore, I just added the logical AND operator and said, and make sure also that it was in 2010. Okay, well that filters out 2 of them. So again, mini method, lambda expressions are just mini methods. So for any given item in the collection, it has to match that criteria, and if it does, then we can add it to this little subset collection over here that I'm calling BMWs. All right. So the var keyword, it has a very different connotation in C# than it does in other programming languages. So here I would ask that you forget what you know about var from maybe JavaScript or Visual Basic or some other programming language. It does not mean the same thing. In this case, the var keyword says that we're going to let the compiler figure out what the correct data type is. I'm not even sure what gets returned from this little query that we do here. If you were to hover your mouse cursor over the where, you can see that it's going to return back an IEnumerable of car. What's that? Not entirely sure. Doesn't really matter. I don't care what it is. I know that it is a collection of cars. And kind of to prove this point, we'll talk about this in just a moment, a little bit later, where the var keyword can really come in handy because we truly don't know what it is that's being created by our LINQ queries. Okay, so again, the var keyword, it's still strongly typed. We're just going to let the compiler figure out what the type is at the point when the code is compiled. All right? All right, so let's move on and let's take a look at a few other examples. So I may want to find a list, an ordered list of cars. So I might go ordered cars equals from car in my cars, order by car.year descending, select car. All right, so that's how I would take all of my cars and order them in descending order by their year. And then let's just change this from BMW. Let's put this to ordered cars, like so. And this might help if we actually saw the year itself. So I'll add in car.year as well. And let's go ahead and run the application. And so you can see it starts at 2010 and in descending order works its way back to 2008. Awesome. All right, so that same query, if we were to do it in using the method syntax instead of the query syntax, it would look something like this. So var ordered cars equals my cars dot order by descending. So given each item in the collection, only return those or actually order them by the year, like so. And we should see the same grouping, and we do. Starts at 2010 and works its way back to 2008. Awesome. So again, in my opinion, this is more concise. The only conceptual hurdle you got to jump over is just make sure you understand what a lambda expression is. In this particular case, it's not a filter. We're just saying, given each item in our collection, we want to order by this particular property, the year, all right, and then add that ordered item to our collection of our new collection of cars over here, okay? Now there's a lot of interesting things that we can do, and I'm only going to work with the method syntax from this point on. So the first we might do something like this. For example, if we wanted to find just the first item, so let's go ahead and grab this, and maybe we want to find the first item where the make is equal to BMW, like so. So this will give us the first car, the first BMW car in the list that it finds. All right. So let's go ahead and console. In fact, let's change the name of this to first BMW. So console.writeLine. First BMW dot, let's go, just the VIN number should be sufficient. Let's run that. All right, so we can find that the first BMW in the list was A1. Or we can do the first BMW, and we can actually start by ordering by descending given the year. So you can see I'm chaining these together. We've talked about method chaining before. This will return a collection of cars, and then this will return a single car in that collection. And then we'll print that single item's VIN out to a window, in this case E5. So the list is first sorted, and then we grab the first one that matches our criteria of BMW, okay? So that's how we can use first. I'll go ahead and comment that out. We can also do something like this, console.writeLine. And inside of here, let's go mycars.trueForAll and say the year is greater than 2012. And need one more right there. So is it true that all the cars in my car lot are, that every one of them is greater than 2012? That would be false, all right? Well then how about, are they all greater than at least 2009? All right, that's still false because we have at least one that was created in 2008. If we were to change this to 2007, are they all at least greater than 2007? True. All right. So that's true for all. Very helpful in order to aggregate and look across all of them and see, is this true for all the items in my list? We can also even do something interesting like this. Instead of doing this for each statement, where it's essentially what, at least 2, if not 4 lines of code, we can create a for each like so. mycars.forEach, and then inside of here, for every item, let's just do a console.writeLine. And in here, I can do P dot the VIN and P dot the sticker price. All right. And so let's go ahead and do that. In fact, we'll just do that as well. Whoops, 1 and 0. Hopefully that all makes sense. Now let's run that, see what happens. All right, so here we are. We're able to list them all out and format their values. So you see how much more compact this looks than what we were writing here. We do it all in one line of code. Again, we're passing in for every single item in our collection. Just call console.writeLine and then use that particular item's VIN and sticker price inside of our formatted string. Okay. Here's another interesting example of this. Maybe in each case we want to go so mycars.forEach. In fact, here, let's do this before that line of code. Let's keep that one and then go mycars.forEach. And in this case, I want to perform an operation on each of the data inside of there. So I might take the sticker price and reduce it by $3,000. Actually, let's go minus equal to. So this will take the sticker price and subtract $3,000 from the sticker price of every car in my collection. So you can see now what was, if we could kind of get a comparison going here. Let's see, unfortunately not going to be very easy to do, but you can see that what was $55,000 is now $52,000. What was $35,000 is now $32,000, and so on. Okay. So again, a lot of functionality in a very small space. Let's continue on with this thought and go and do something like mycars.exists. Do we have a car in our car lot where the model is equal to the 745 Li, true or false? And here we'll just do a console.writeLine, and so this will either turn true or false. Yes, we have at least one item in our inventory where the model is equal to 740 Li. Great. Now here's another good aggregate function. Here, let's just do console.writeLine, and let's go mycars.sum, and here we'll say sum up all the sticker prices. Let's see what the total value of our car lot is right now. And you can see that it's about 247,000. So actually, there should probably be a better way to format that using a format code, but hopefully you get the idea. We're able to sum up a single field across all objects in our collection of cars. All right? All right, and there's so many other things that I can show you, but I don't want to overwhelm you. But I want this just to go in one ear and out the other for now. This var keyword we've looked at, and I said that we use it because we want the compiler to figure out what the data type is. Sometimes it's easy for us to figure out what the data type of something is. Sometimes it's not so easy. So to kind of illustrate this, let's do a console.writeLine, and what I want to do is call on my cars, I'm going to call the get type. In fact, all data types in .NET have this get type method declared because it is it's declared on the grandparent of all objects called system.object. It defines this method called getType, which will tell us what the type of a given object is, and we can print it to screen. So in this first case, what is my cars? Well, my cars is a generic list of the car data type. So this understanding link is the namespace, and specifically though it's the car type. So we're basically saying this is a list of T, a list of car, right? So that's what's being printed out whenever we're looking at what the cars are, and that's pretty easy to see because we defined it here. But once we perform an operation like one of these here, let's just see, ordered cars, we'll copy that again and stick it down here. And then I'm going to do console.writeLine ordered cars.getType, and it'll show us what the data type is for ordered cars. Let's go ahead and compare the two. All right, now in this case you can see that we're no longer dealing with a list of car, even though under the hood we know we're working with a list of cars. The way that it's represented in .NET is that it's actually an ordered enumerable, so an ordered list of of the link.car, understanding link.car. Okay, so again, okay, that makes sense. That's an ordered version of cars. How about just a regular old where statement? So let's do that. Let's copy that and see what the data type of that is, and then do the same sort of thing here, where we're going to see what that is. Let's go ahead and run the application again. All right, here's this third one. So this second one was an ordered enumerable. Then the one where we just called the where was an enumerable plus the where list iterator. All right, so things are starting to get a little funky here, right? It might be difficult for us to be able to express this ourselves if it were not for this var keyword. And so the var keyword is essential to help us to be able to create these very complex queries and not have to worry about what the data type of it is that's returned. We know that it is a type of list. It's an enumerable list, whether it's ordered or not, and we can for each our way through it, or whatever the case might be. Now the last thing that I want to demonstrate is I'm going to take this this first query here, and I'm going to pop it all the way to the bottom. Again, if this stuff doesn't make sense, don't worry about it too much. I wanted to go in one ear and out the other, just to kind of explain again the value of the var keyword. In this case, let's change something about this. Let's call this my new cars. All right. And here I'm not going to return cars. I'm actually going to do what's called a projection. I'm going to only take certain values, certain properties of a car, and I'm going to project them into a new data type. What's the name of the new data type? Where am I defining that data type? I'm not going to define the data type. It's an anonymous type. What's the name? I have no idea. It's anonymous. All right. So we can define types at runtime and only choose those properties that we need in the type for the moment. Why may not be obvious just yet, but I want you to understand that there is this idea of what we can do here. So in this case, let us merely let's pull out just a few things, like the car dot make and the car. Whoops, I'm sorry. This should be select new car.make car.model. That's all we want. We're going to leave all the other attributes of car alone. We're going to only take these two values, put them into a new anonymous type. Where's the type defined? Nowhere. We just made it up off the top of our heads. And we're going to save each of those anonymous types into a new collection of anonymous types. All right. All right, so let's go console.writeLine and then take a look at new cars.getType. And let's run the application yet another time. All right, and so this time you can see that we also here have an enumerable plus where select list iterator, whatever that means. But then notice that the data type involves something called an anonymous type that has two attributes, two string attributes, which would be the make and the model. All right. And so I say all that to say this, that whenever you're working with LINQ, there's a lot going on under the hood to make it all very easy and accessible, but it all depends on defining your types as var, which says we'll let the compiler figure out what the type is. We're not so worried about it because the data type might be so crazy that we can't even comprehend what it is. All right. So hopefully that makes sense. Just to kind of recap the things that we talked about the difference between the query syntax and the method syntax. We looked at a number of different examples of the various link extension methods that were available. We saw how we could kind of break apart an individual lambda expression to better understand that essentially we're saying each item in the collection, run this little mini method against it, and return back a given item that matches that criteria. And then we looked at how to tell what the types were and what the value of the var keyword is, and then we looked at anonymous types. All right, so we covered a lot of ground. I didn't explain everything in great detail, but the key here is just to kind of look at that little formula and try to understand what it needs. Look for examples online. Make yourself a little cheat sheet, and you should be able to utilize these methods inside your own application. All right, so that wraps up LINQ. This will be the hardest thing that you have to think about today, I guarantee it. All right, so that's it. We'll see you in the next lesson. Thanks. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we will introduce a new decision statement. The if, else statement and the conditional operator are both great. They work best when there's only a handful of things to evaluate. But if you start needing to evaluate many different potential cases, you might find that the switch statement is a little bit more concise and keeps things a little tidier. And that would probably be one of the only reasons why you would use it, and I'll show you a second reason why in this video as well. So we'll come back to the switch in just a little bit, but first I want to talk about a special data type called an enum, or an enumeration. Typically, we want to limit the possible values of a given variable. Now, admittedly, we're already limiting the possible values that can go into a variable by virtue of the fact that we've given it a specific data type. However, even within that, I may want to limit the number of possible values to just a handful. So typically in software development, you want to limit and constrain your data to ensure its validity inside of your system. An enumeration is a data type that limits and constrains all possible values to only those that are valid and have meaning within our system. So, for example, we might want to keep track of a series of to-do items. Maybe that's the type of application we're building. And each to-do item is represented by an instance of a to-do class. And so we may want to keep track of the current status of a given to-do item on our list. And so we may want to constrain the possible statuses to maybe like 5. That the task has not been started yet, or it's in progress, or it's on hold, it's been completed, or perhaps it's been deleted. There might be some other statuses, but you can see how I may want to just limit the number of options that are available for a status field or status property of my to-do class. So we could do this a number of different ways. We could just concoct a numbering scheme where 1 is always represents not started and 2 represents in progress. But numbers are, I refer to those as magic numbers. They may have some meaning in the system, but it's not readily obvious if you're reading the source code. You know, as the developer, you may have to look up at some external reference, maybe some code comments, and who knows, maybe those aren't even, maybe they're not even current anymore. Maybe things have changed since whoever wrote those code comments originally wrote them. So I may need to reference or look through a number of different code to ensure that what number 1 means in the system, what number 2 means in the system, and so on. The same thing can be true with strings. I could just use a literal string to indicate the current status. So I could use a literal string, not started or in progress. But the problem with literal strings is that somebody can mistype them, or they could be there could be a space and not started one time, and then somebody uses not started without a space the other time. And so they may not, if you're looking for all those items that have not been started yet, you may have a hard time finding those that have not yet been started or are in progress because they're not spelled correctly or whatever the case might be. So the great thing about an enumeration is that it gives us a textual equivalent to a numeric value so that it'll remove any ambiguity inside of the system. As developers, we know exactly what we're working with, and yet behind the scenes it's still working with a number. And enumerations are used frequently in the .NET Framework class library for the very same reasons. So for example, you can see here that I have a project, enums and switch, and here again, if you look in the code folder for this lesson, there should be a before and after. You want to copy the enums and switch project from the before folder and copy it into your projects directory so that you can catch up to me where I'm at this moment. You can always pause the video and type all this in if you like. It'd be quite a bit of typing though. You can see that in this project I've already created a to-do class with a description of each to-do item, the estimated number of hours it should take to complete the to-do item. And then notice that I have a status of type status. Where does this come from? Well, you can see directly below I've created an enumeration called status. And I have not started, in progress, on hold, completed, and deleted. Did you notice as I hovered my mouse cursor over it that each of these values are given a numeric value? So not started equals 0, in progress equals 1, on hold equals 2, and so on. If we were to store these values somehow in a database or a text file, those are the values that might actually get stored. However, they will be translated into this more textual format so that when we're actually working with the data, as you can see here in the static void main, as we're creating a new list of to-dos using the collection initializer syntax, here I'm setting the status equal to either completed or in progress or deleted or not started and so on. And visually it's much easier for a developer to work with those options in a more textual sort of way. Now the .NET Framework class library will use enumerations extensively. In fact, even in the console window, if we were to set the foreground color, notice that IntelliSense automatically pops up to the console color enumeration. See, it says enum over there. Whoops, let's see, I don't think you can see that. Let's go up a little bit here. All right, there. Okay, so now you can see the word enum right here. It's console color enumeration, and when I hit the member access operator, the period, it will show me all the colors that we can choose for the foreground color of our console window. So I might choose dark red. Okay, so again, enumerations are great because they are descriptive and they limit the number of possible values for our applications, for the properties of our classes. All right, the next thing I want to talk about is the switch statement, and these two are going to marry together here in just a moment. But a simple switch statement is going to look something like this. In fact, I'm just going to go switch tab tab, and that will create essentially the outline for it. And in this case, we could do something like we can use an individual to-do item and choose its, let's say estimated hours. And so if the estimated hours are, for example, case 4, all right, then we might perform some operation until we hit the break statement. Or we could go case 5, so we could perform something and then we would hit the break statement and break out. There's also a default case that would be the catch-all, just like the else statement in the if, else construct. But the most important aspect of this is the construct of the switch statement. You have the keyword switch, then you have a value, a variable that's under evaluation, and then a series of cases where we would try to match it up with one of these cases, and then we use the colon after that case. We write our code below it, and then we use a break statement to break out and continue on our execution of the code. Now we might choose to, for example, do something like this. This makes a little bit more sense to work with the statuses. So in this case, we might go status dot completed. We might do something versus case status dot deleted, and we might perform some operation there, and so on. Now the beauty of the switch statement and the enumerations are that they kind of can conspire together here. So watch what I do. I'm going to type switch tab, and then I'm going to go to do, which is each of the items in the to-do collection, dot status, and then I'm going to hit the enter key on my keyboard twice. And the second time I hit enter, see the macro that will actually blow out each of the individual statuses so that I can write code associated with each status. All right? Isn't that crazy? And so now I can do here, anything that my business logic would require. I have an idea though. Let's use the foreground color and change it up for each of the individual to-do items. So it can be as simple as this. Let's just copy this and we'll put it here for each of these statuses. And then here at the very end, we will actually then do a console.writeLine of the actual item itself, the to-do dot description. And here we'll change up the color. So if it's not started, we'll leave it as dark red. If it's in progress, we'll use green. If it's on hold, maybe we'll use the dark red. Let's use the red here and the dark red there. Completed, let's mark those as blue. And if it's been deleted, we'll mark that with yellow. Okay. All right, so now let's go ahead and save and run our application. And you can see we have a very colorful list of tasks that are color-coded by their current status. All right, see how cool that is? All right, so in this lesson we talked about enumerations and why we would use an enumeration to constrain the possible values for a given property of our classes. And we saw how it was used in the .NET Framework Class Library, one little instance of it here, where they've created their own enumerations. Just be aware of, as you're trying to work with a given class and its properties, always look at, for example, in this case, what data type it is. So this is a data type console color, and typically IntelliSense will point you kind of in the right direction. As you hit the equal sign, it will pop down to that data type, that enumeration, so that you can just hit the period and then you can make your selections there. So that's a really good hint. And then we looked at the switch statement, the structure of the switch statement, where we're evaluating something in between the opening and closing parentheses. We looked at the body, the opening and closing curly braces, the entire body of the switch statement, and then inside the creation of a number of cases, each case equating to one possible value of the item that's being evaluated, and then a colon, and after that, then any of the code that we want to write, and finally a break line which will pop us out of that switch statement's body. And then finally we saw that there is a catch-all, the default colon, which we can use to write any code for cases that we haven't accounted for in any of the other previous cases. Okay. All right, so that wraps up this lesson. Doing great. We're getting close to the end now. You feel pretty confident in C#. You've got the majority of it under your belt. Just a few more topics we want to cover, and then we'll wrap this up. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devview.com. In this lesson, we're going to talk about handling exceptions that occur within our applications. We'll discuss what can go wrong, why things go wrong, and how to build resilient applications that are impervious to crashing through the use of C#'s try-catch block statement. So when the compiler catches a data type mismatch or an unresolved reference to a class or some malformed C# instructions, it'll refuse to compile your C# code into a .NET assembly until you fix the problem. These type of errors are called compilation errors, and that's not what we're talking about in this lesson. However, there are other types of errors that happen during runtime, or in other words, they happen when the compiled .NET assembly is actually in the act of executing. And honestly, there are countless number of reasons why you could encounter an exception while the application is running, depending on the kinds of things you're trying to do in your application. And many times, these things are outside of the direct control of the software developer. So for example, if your application can't read or write to disk because a folder or a file is missing on disk where it expected to see it, it could trigger a runtime exception. Or maybe the file's corrupt, or maybe the network access to that resource is unavailable, or attempted perhaps to access a database and it couldn't find something in the database that it needed, a table, a column, whatever the case might be, because the structure has changed of the database out from under the application. All of these things and many, many, many more could cause the absolute failure of your application. And the user will see a nasty error message at runtime, and they'll in frustration say, the developer. So in some cases, the developer may have not even foreseen that could have potentially been an issue. And so if they didn't see that it could be an issue, they couldn't have accounted for it. Maybe the developer, for example, allows the users to type in a country, but the user misspells the country name. Now, maybe they did that intentionally or unintentionally. Perhaps they maliciously use numerical characters instead of alpha characters. But as a software developer, your job is to make sure that you account for all of these possibilities. A friend of mine was fond of saying that 80% of all code exists to solve 20% of all the potential problems that could happen in your application. So generally, software developers should be pessimistic regarding the reliability of everything outside of their control, whether that be input from an end user, any connection to a network, to the file system. Anything that the developer cannot directly control should be held in great suspicion. So again, if you rely on a file or a network resource, you should treat it with great suspicion. If you rely on the user to type data into your application, definitely treat that with great suspicion. It's absolutely evil, okay? So this is the software developer's equivalent to driving defensively. Always code defensively, which means you are always looking for problems all around you all the time. Now, the way that the C# developer codes defensively, or one of the ways in which they do it, is through the use of a try-catch block. And I'll demonstrate that in this lesson. Up to this point, we've been reading or actually writing files to disk. This time I want to read a file to disk. We use the same file class like we've used previously. And notice that I already have a using statement for system.io, so it finds it. And this time I want to use the read all text instead of the write all text. And here, let's just go ahead and set this example up. Notice that I've already got a project created called Handling Exceptions. Please pause the video and catch up with me if you like. But here we go, string content equals file.readAllText. And then let's just, for the sake of argument, hard code a location. I'll put this at lesson22.example.txt, and then we'll do console.writeLine the content, and then finally console.readLine, like so. Great. All right, so far so good. And now here I just want to demonstrate that this actually will work. So you can see that I created off my root a lesson 22 folder with example.txt in it. Let's go ahead and run the application and show that there is actually text in that file. It's just a quote from Mark Twain. And now that we've got it working correctly, let's let's break the application by giving it a fake name, just by removing the E on the end of example.txt. And now you can see that we get an exception. This is a file not found exception, was unhandled. And so I'll tell you what, let's do this. Let's stop the application. That's what the developer will see while they're debugging their application if they were to run across this issue while they're building the application. But what if we were to build a release version of the application by changing the solution configuration and then selecting build solution? Now we're going to go out to our projects directory, and I'm going to act like an end user and actually attempt to use this application outside of Visual Studio, so outside of the debugging environment, just to see what the end user would see if they ran into this exception at runtime. The name of this is handling exceptions. All right, there you go. And let's go into the bin directory, into the release folder, and I'm going to double click the handling exception, and whoops. Notice that I get this ugly little message here, and it's trying to help me figure out what happened, and I get all this text here with all this ugly information, just spewing out all this information that an end user probably would have absolutely no idea what the issue was. Although we can read here near the very top that the problem is that it couldn't find the file lesson 22/example with no e.txt. Now, a very observant user might be able to look at this and figure it out if they stared at it for a while, but most users are going to be scared off by this, and I don't blame them. So we ideally would like to make sure that the end user never sees anything like that whenever they run our application. So again, Windows will then close the application, notify you if there is a solution available. There's just a mess going on there, and we want to protect our end users from this mess, from ever seeing this. So what we can do is actually wrap a try statement, a try and a catch around this. So we'll do this, and there's a couple different ways to go about it. I'm just going to take the easiest approach to begin with. And what I might do is just go ahead and let's switch back to the debug configuration and run the application. Now, you may have noticed that the application ran briefly and then went away. And the reason it did was because we ran this, we hit an exception here, the catch statement kicked in, there's nothing defined in the catch statement, and we continued on. What if we were to move this to right there? We would at least see the application now run for a little bit, and we would see no output. So still not an ideal situation, but at least we're not seeing any exceptions. Let's go one more step with this and say let's actually catch the exception that occurred. So here we're going to catch an exception call that we're going to call EX. Now, exception is the most general type of exception that can be thrown. What we're going to look at in a few moments are very specific versions of exceptions, but this is the most general version so that at least we can see what the problem is, and we might do something like, you know, there was a problem, something like that, and even we could provide a description of the problem, so the message from the exception. So let's go and run the application, and at least this time, you know, at least we're giving the user some feedback here. There was a problem, could not find the file lesson 22/example.txt. Okay, so that's better. Again, it would require an observant and slightly more technical end user to be able to resolve this issue on their own, to say, wait a second, I wonder if that file might be named something different here on my own hard drive, as they traverse through and look for the file, and they're like, oh, I see what the problem is. There's no E on the end of example. All right, that's asking a lot of your end user, but that at least is a step in the right direction. At least we're giving them some clue as to what the issue is. Now, really what I would like to do is account for all the possibilities and be a little bit more specific. So if I were to hover my mouse cursor over this read all text where the issue seems to be mostly, you'll see that we've only been looking at the return value and the input parameters for a call to a method. But notice below that there's a list of possible exceptions that could occur. Also, if we were to go to system.io.file.readAllText, so let me just copy this, pop open, and let's go to Bing. We're basically going to be searching through Bing here for system.io.file.readAllText. That should help us find an article in MSDN that has a full description of this method. You'll see that there's two overloaded versions. We're using this first overloaded version of it. And then if we were to scroll down and past some of the initial information, there's a list of exceptions, and it would provide us some scenarios why that particular exception might happen, like a security exception. The caller doesn't have the required permission. All right. The path is in an invalid format. Interesting. File not found. The file in the path was not found, and there's also a directory not found. Interesting. Okay, so maybe the path was too long, or maybe we provided a null value. So there's a lot of things that could potentially go wrong whenever calling this method, and as developers, we really need to the extent that we can, account for all those potential situations, at least the ones that make sense. So, for example, I could rewrite this code example to begin catching some of those specific examples. So, for example, let's take a look here. Let's first of all make sure that the directory exists, and then if it does exist, then we'll check to make sure the file exists. And so then if the file and the directory exist, but we're still getting exception, then maybe we let it drop off to this most generalized exception here. So I'm going to start from the most specific case and then work my way to the most general case. In this case, I think the file not found exception is probably the most specific of the ones that we're going to work with. And then we'll catch the directory not found exception, and then if that doesn't work, we'll just print out whatever the exception was. So here I might do something like console.writeLine and say there was a problem, and then give it a specific. Make sure the name is name of the file is named correctly. Should be example.txt. All right, and then we can do something similar here and say there was a problem. Make sure that the name of the directory. Directory. Make sure the file, make sure the directory c:/lesson22 exists. All right, something like that. And remember, we're getting the red squiggly. Why? Well, because we either need to add another backslash here or add the @ symbol there. Remember that from earlier? Okay. So let's go ahead and test our application, and I'm going to set a breakpoint here whenever we hit this line of code so that we can watch this execute. All right, so let's go ahead and step over, and it looks like it found the file not found exception, and so we will see there was a problem. Make sure the name of the file is named correctly. All right. Then let's go out and let's rename this to lesson 22A, and I think we're still going to get the same actually exceptions. So maybe that's oh no, we did get the directory not found exception. Good. Okay. So in this case, we'll see that error message. Make sure the directory lesson 22 exists. All right. And then for any other exception, maybe there's a permissions issue on the computer. Maybe there's the file is corrupt somehow and we can't read from it. We would get this last catch-all where we catch just the general exception and print it to the user. Okay? So at any rate, the key to this is that we check the most specific exceptions first and the most general or generic exceptions last. There's also one other item I want to add here, and that's a finally statement. And this is where we would write any code to finalize, which might mean setting objects to null, closing database connections. All right, but this code is going to run no matter what, and so we're just going to go console.writeLine, closing application now, like so that we can see that this code will run regardless. It's just that one last chance as a developer to clean up our mess before we stop the execution of the application. So, and you can see that now represented here by closing the application now. Great. Now you might look at this and you might think to yourself, okay, great, I'm going to use this try-catch around everything in my application. Every single line of code in my application, I'm going to wrap it with a try-catch. So I'll just take every method and I'm going to blindly just copy and paste everything in there. And that's definitely a strategy that some people take. It's a little bit lazy, quite honestly. Some developers have done that, but they're often ostracized by their end users for providing very cryptic error messages. So if we were to, leave all of these off and just wrap everything and just only show the exception EX, we would just be saying, hey, there was a problem here, figure it out for yourself. That's not really advocating on the part of the user, right? We're not protecting the user. Furthermore, we might be tempted to provide some type of debugging information for ourselves as developers. Sometimes you'll see some error codes pop up that no human could be expected to understand except the guy who originally wrote the application. The reason developers do this is because sometimes they take that exact approach where they just say, hey, we're going to forget about the user, I'm just going to wrap everything in a try-catch, and it'll pop the error message to me, it'll float back to me, I'll fix the problem, and everything will be okay. But again, this catch-all is convenient to the developer, but it's really frustrating to the end user, so you shouldn't do that. You should strive to put the same amount of attention into protecting your user from having these sorts of issues and protect them from having to guess at what to do next by simply helping them fix the problem. Tell them specifically if you possibly can. If you, the developer, can fix the problem, or at least you can point the user in the right direction, then that's awesome. You should do that. But if you can't, well then at least try to identify the exact nature of the problem and then ask the user for the type of input that you would need as the developer to fix the issue. You don't want to leave your users feeling stupid that they did something wrong. You want them to feel empowered, and you want them to feel like your application is well built and it considered them whenever you were building it. So that's what makes your application polished. It's what users expect, a reliable experience with no surprises. All right. So to recap this lesson, we talked about a number of different things related to exceptions that can happen. Essentially, anytime that you, the developer, are not completely in control and you're accessing things outside of your boundary of control, outside of your domain, you need to wrap those in a try-catch and be thoughtful about the types of exceptions that you'll be handling. Listening for specific exceptions that a particular method could raise, and it's easy to find out. All you got to do is hover your mouse cursor over it, or you go to MSDN and you find that method, and you look for, like we did, all the potential exceptions that could happen, and then be reasonable about it, but then write the code necessary to handle those exceptions and protect your end user. We looked at the try, the catch, We looked at catching the exception and then using certain properties of the exception, like the message property, to print out to the user what the issue was. We could also use this to log the error, even send it to a centralized logging service like Application Insights that's available from Microsoft Azure to report back to the developers what the issues were. And then you can use the finally code block to clean up any connections you have to file systems, databases. You can set objects equal to null and go ahead and remove all of your references and be very explicit about that before you shut down the application. Okay, so hopefully that was helpful. This is a great lesson in building resilient applications, giving the users the kind of experience that they would expect whenever things go wrong in your apps. All right, so we'll have one or two more lessons and then we're done. We'll see you in the next lesson. Thank you. Hi, I'm Bob Tabor with Developer University. For more of my training videos for beginners, please visit me at devu.com. In this final tutorial video in this course, we're going to discuss event-driven programming. Event-driven programming is really at the heart of Microsoft's presentation APIs, whether it be for web or Windows. And really, for that matter, it's at the heart of just about every other API in the .NET Framework class library. It is so essential that we have to spend a little bit of time here near the end talking about it, because it's that next step that'll help you graduate onto building real applications with real user interfaces beyond this course. So events allow you, the developer, to respond by handling those key moments in the life cycle of the application's execution, allowing you to write code to respond to an event being raised. All right. So up to this point in our simple console window applications that we've been building, there's really only been one event that ever gets fired off, and that is the application startup. So on application startup, the static void main is executed, so it's handling that event, I guess you could say. And this is where we write the majority of our code, and that's why it actually executes whenever we run the application. Now, in a modern user interface, whether it be for Windows or for web, users can interact with the various elements that they see on their screen. So they can hover their mouse cursor over given things like buttons or graphics or text boxes, and they can see maybe a change in the visual presentation. Maybe they see a pop-up that explains the usage of that given item. Perhaps they can click on an item to enact some business functionality inside the application. They can press keys on the keyboard to make things happen. They can type inside of text fields, or they can drag and drop items around the user interface. And each of those will raise a number of events. So as a software developer, you can decide to write code that responds to those interactions between the end user and those various user interface elements on screen. And you can also choose to ignore those that really don't make sense, that you really don't care about, you don't implement for your application. So a given component, let's say a button, for example, in its development by Microsoft, they included or defined an event. Let's say it's the click event for that button. Now, the developer, you and I, we say, hey, I want to write code that performs this business logic that I'm writing here in C# whenever that event, the button's click event, is raised, then I want this code that I write to be executed. So the developer creates a method and attaches that method to the event, and I'll show you how we do that in just a little bit here. So as the application is running, the user is interacting with the application. Eventually they click that button. The .NET Framework runtime says, okay, if you were listening for the button click event, here it is. It just happened. And it will notify every one of the methods that you and I as developers have attached to that specific event notification, all right, that we've registered to that event. And I'm going to show how events are used in a simple Windows application near the end of this video in a more realistic scenario. But first, I want to start with the absolute basics and keep things as clean as possible. So we're going to work purely in a console window application. And we're going to work with a timer class, a timer object, and it has one event, which is elapse. So we can say after a certain amount of time, we want you, timer object, to execute or to raise an elapsed event, and then we're going to attach our code, our event handler code, to that event so that it gets executed every time that event is raised. All right, so maybe it'd be easier to see this in action than explain it. There are a number of different timer classes inside of the .NET Framework class library. We want to make sure we get the right one. So I want to work with system.timers.timer, okay? And I don't want to use that long name every single time. So I'm just going to add that to my using statements up here at the top, like so. And I'm going to say timer my timer equals new timer. And one of the overloaded versions of the constructor for this timer class allows us to pass in the interval in milliseconds. So every, let's say, 2,000 milliseconds, we want the elapsed event to fire, to be raised. All right, so 2,000 milliseconds would be simply 2 seconds, all right, which is an eternity as far as a computer is concerned. Okay. Next up, what we're going to want to do is say, all right, my timer, we know that it will raise an event called elapsed. And so we want to create an event handler, a method that will be executed whenever the elapsed event is raised by the .NET Framework runtime. So here you can see that we get this little message on screen that says press tab to insert, and I press tab, and it automatically creates the method stub called myTimerElapsed. So, and it creates it in a very specific way with a very specific method signature. And it also gives us this little stubbed out, hey, don't forget you did not implement me. So throw new exception, not implemented exception. Let's go ahead and remove that for the moment. But notice what happened here as well. So we are attaching or registering an event called myTimerElapsed to the elapsed event. So this references this code block right here. Okay, and so inside of here we can write the code that we want to execute each and every time the elapsed event is triggered inside of our application. So this is where I might write something like a console dot writeLine, and the elapsed event will send along some event arguments. And one of the interesting event arguments is actually the signal time, and that will give me the exact down to the millisecond when that particular event was erased. Okay, so here we go, and I'll just go, actually let's do it this way so that we can format it nicely. We'll call this elapsed, and then hour, minute, second dot FFF. That should give us down to milliseconds. Okay. And now what we'll do is actually tell the timer to start ticking by calling the start method. And then we're going to go console.readLine, and we're going to say continue running until somebody hits the enter key on the keyboard. Okay. Hopefully that makes sense. And let's run the application. And now we see every 2 seconds we get this message. So you can see at 32, 34 seconds, 36 seconds, 38 seconds, plus some 1,000 milliseconds there, we get that myTimerElapsed method executing. All right. Now let's do this. Let's say that we want more than one event handler to execute whenever the event is raised. So I can do this all day long. I can say, hey, well, let's go ahead and add another method. This time it'll be called myTimer_elapsed1. Notice the 1. Here I'm going to get rid of this little box again. And inside of this new method, I can do essentially the same thing, and I'll just use that elapsed1 versus elapsed. In fact, just to make this obvious, I'm going to use that little trick we learned just a lesson or two ago, where we set the foreground color equal to the console color dot red. So that will be for the second one, and then we'll do console dot foreground color equals console color dot white. All right, so we can see clearly the two different event handlers that are both executing whenever the elapsed event is raised by our timer. So let's run the application. All right, and now we see the pair running every 2 seconds. All right, and we could continue adding additional event handlers to the event. All right, so that's what this little operator is doing. It's saying how many current items are subscribing or have been attached to this event. I want you to attach this other one too. Okay. Now we can do the opposite as well. In fact, let's go console dot write line, and we'll say press enter to remove the red event. All right, probably a better way to say that, but hopefully you get the idea. And so then after this read line, we'll add another read line for the very end of the application. And in between, what we'll do is actually unregister, detach this second event handler for this event. So we'll just do the reverse. myTimer.elapsed minus equals myTimer.elapsed1. So now we have removed it, and it should no longer execute whenever the elapsed event is raised. So let's run the application. All right, so you can see, here we go. And now I'm going to hit the enter key on the keyboard, and we should only see the white, the first version of our event handler firing every 2 seconds. Okay? Hopefully that all makes sense. All right, so this is the most simple scenario that I could think up without having to actually create a real application. And by real application, I mean one with a graphical user interface. But now that we've broached that topic, let's go ahead and build an example WPF application. WPF stands for Windows Presentation Foundation. It's one of the APIs inside of the .NET Framework class library that you use to build Windows applications. In other words, applications that are executed on the Windows desktop, not web pages that are executed on a server and their markup is delivered into a browser, but a true application that's running on the end user's desktop. So I'm going to go File, New Project, and here I want to make sure to choose WPF application. It should be one of the templates that are installed in the New Project dialog. And what I'm going to call this is WPF Events, like so. All right, and then click OK. And this is not going to be a tutorial on how to create Windows presentation, application, interfaces, or how to work with it, but I just want to show you the basics are generally the same. So here we have a basic application. We can actually run the application. It'll do nothing at all. We just get a white form on screen. But I want to go to my toolbox over here on the left-hand side. I'll even pin it down briefly. And then inside of here, what I'm going to go is to this rolled up area called Common WPF Controls. Now, what you see on screen might be a little bit different than what I see on my screen. Okay, just make sure you're working inside of this main window.xaml and that you see some visual representation of your form here in the main area. All right, you could ignore everything below. That's the actual markup that will generate what you see visually here. We're only going to work with the visual editor, but know that there's some markup that's going on to produce this, okay? But again, that's a topic for another day. I'm going to drag and drop a button onto the design surface like so. I'm going to go over here to the properties window on the right-hand side. And this will allow me to set various attributes of that object, that visual object. So for example, I can change the content to click me, all right, like so. I'm also going to add a label control. I'm going to drag and drop it anywhere on this design surface. I'm going to remove the content completely, but I'm going to change the name to my label, like so. Okay? Now what I want to do is print out the phrase hello world whenever somebody clicks the click me button. I'm going to choose the click me button again by selecting it here in the visual editor, and then I'm going to look for this little lightning bolt over here in the properties window and click the lightning bolt, and this will show me a list of all of the events that this single control, this button can raise. Now, a lot of these are going to be for very specific situations, and we can ignore the vast majority of these, but the most important one here at the top is the click event. Now, I can write C# code that will execute as a result of this click event being raised by the .NET Framework because somebody, the user, clicked on that click me button. So I'm just going to double click here in this white area, and when I double clicked in the white area, it created this button click method stub. All right, so this is going to be my event handler code. Let me use the auto hide pin to get rid of that so I can see this. And here what I'm going to do is type in my label dot content equals hello world, like so. And then I'm going to save my work, and then I'm going to start the application by running it. I'm going to click the click me button, and it displays the word hello world inside of the little label. All right. Now, what you didn't realize is that maybe that whenever we double clicked inside of Visual Studio in this little white area right here, it created a event handler for us, and it wired up or attached or registered that event to this button. You might wonder, well, where is the code that looks something like button dot click plus equals, where's that code at? Well, that's a little bit difficult to describe. If you take a look at this markup code here at the bottom and we scroll all the way to the right, that is essentially what happens right here. This code will get converted into C# at the point of compilation, and it will create that little snippet that we were used to looking at in the previous code example. However, I can create a second event handler in C# by doing this. Let's go to the toolbox, and I'm going to actually grab another label and just plop it down anywhere. And I'm going to select that label and then go to the properties window, and I'll change this to be named my other label. And then I want to change the actual content of that label to be blank as well. All right, so now what I want to do then is go to the main window.xaml.cs, and here I'm going to go button underscore dot click plus equals, and I'm going to click and I could click tab to insert, but I'm not going to do that. I'm going to name this manually myself, button my other click, like so, and then I'm going to hit enter on the keyboard, or actually I'm going to hit that. And now I'm going to, you can see that I get a red squiggly line. I'm going to put my mouse cursor on that line and hit control period, and then choose generate the method button underscore my other click, and it does it for me. And you'll see something that looks very familiar here, a method stub with the not implemented exception. And here I'm going to say my other label dot content equals hello again, like so. All right, so now if I did this correctly, whenever my user clicks the button, it will not only fire off this event handler, but then also this event handler. And this event handler we wired up manually using the technique that we learned in the previous code example. So let's just run it and make sure this actually works. And it does. All right. So the same principles are at play here. The difference is the vast number of events that are accessible to every single visual control in your toolbox whenever you're working with the Windows Presentation Foundation API. All right. All right, so the main takeaway of this lesson is that events are all around us, and especially whenever working with Windows and web applications, we're going to write our code in methods that respond to specific events that are raised by the .NET Framework runtime in response to events that are published by the various objects inside of our Windows apps, our web apps, and so on. Okay, and we can either rely on Visual Studio to wire things up for us in a very quick and elegant way, like we saw here in our XAML code, where we let it essentially do the wiring for us, or we can take control of that process of wiring, of attaching, of registering an event handler to a specific event, and then write the code ourselves to actually respond to that event being raised. Okay, so again, extremely important. Hopefully that's the next logical step for you, is to move on to other APIs, whether it be something like ASP.NET or WPF, like we've worked with a little bit right here, or the Universal Windows Platform to build Windows Store applications. And you'll need to know these concepts for all of those. And that pretty much wraps up this lesson and this entire course. We'll have a couple of closing comments in the next video, and then that's it. So we'll see you there. Thanks. So congratulations, you did it. You made it all the way to the end. That's a huge accomplishment. Don't sell yourself short. When I look at the given views for a course, I'll typically see the first 2 or 3 videos in the course have an astronomical number of views, and then it begins to tail off over time until you get to the very end, and well, you see a rather small percentage of those who started actually finishing the course. And that used to concern me, thinking, well, maybe I could be a little bit more engaging and keep people's interest longer. But the good folks at Microsoft Virtual Academy assured me that that happens across the board with every course. So I think what's really going on is that everybody has the best of intention to follow through, to watch an entire course, but then life happens, distractions pop up, maybe changes in priority, present themselves, they interrupt or completely halt progress. But the good news is that is not you. You were able to make it all the way through to the end, and now you're well on your way to mastering C#, or at least learning more about C#, and then from here learning more about .NET, picking a user interface technology, whether for web, Windows, or mobile, maybe learning more about databases, to maybe using C# to access APIs around the internet. And we'll talk about some of those things that you could learn as you move on from here a little bit later in this video. But soon you're going to be building your own applications, whether for yourself, for your employer, maybe your future employer. But whatever the case might be, congratulations. I really encourage you to continue your momentum. Don't stop here. Keep pushing forward. Keep taking baby steps on a daily basis. As you know, daily progress, no matter how seemingly insignificant, is how you make real improvements in your life. It's how you add skills to your skill set. And you've taken this great first step in the right direction, and I'm proud of you. Can't say that enough. Great job. And I'll continue to encourage you throughout this lesson. But I want to wrap up the series in this lesson and provide a few suggestions about where to look for answers whenever they pop up from here on out, as inevitably you continue by building applications and learning more about the various APIs that are available to C# developers. We're also going to talk about the right way and the wrong way to ask for help out on the internet. And then I'll make a few suggestions on topics that you might want to investigate from here on out as you continue your self-directed training. But before I get started in earnest, let me say that some of the ideas that we talked about here, especially some of the more advanced concepts that I hinted at or that I said, okay, you can let this go in one ear and out the other, just wanted to show it to you real briefly. Some of these things could require weeks or months or even years of thought work before your mind is really able to accept them and digest them. I mean, I know I've personally spent hours just staring at a wall, thinking about some programming concept, trying to wrap my head around it. The mind needs quiet time to reflect. You need to put yourself into a position to succeed by giving your mind the time to discover, the time to ask the crucial questions, the time to allow those neurons to make those vital connections. Honestly, there are things that I learned about 10 years ago that I'm still trying to really wrap my head around, figure out what this means overall, in what contexts it applies, things like that. And many times I might need to read different books and articles, watch videos, and to hear what different authors have to say about a given topic before it finally resonates with me and I really understand what the topic is, how it pertains to me, what do I need to do with it, things like that. Each author who talks or writes about a given topic can say things in just a little bit differently, and sometimes that can finally unlock something for me. So don't forget to keep pushing forward and keep learning, because there's always answers out there. But ultimately, I hope you realize that you really don't need to know everything right away to get started and to be productive right now. You don't have to be an expert first before you can begin to write software. In fact, some concepts really only make sense after you have more experience. Once you've made some mistakes, or you can see where a given idea, and oh, I see where that applies. I could use that here in this scenario. That finally makes sense to me why I would want to do that. So object-oriented programming is a good example, and there are some others too. So I titled this lesson, Where Do You Go From Here? And my intent was to answer that in two different ways. So first of all, where do you go from here whenever you have a problem and you're having a hard time resolving the problem and getting back on your feet again? Well, there's a good chance at some point as you're learning, as you're building applications, you're going to run into error messages or something that just doesn't make any sense. It happens to everybody. But I would encourage you to not fret. I think, in fact, what makes programming such a vital skill is learning how to solve problems that combine your existing knowledge with your ability to reason through what could be the problem, and then your ability to research and perform research on a given problem until you come up with a solution to it. And the good news is that there's this large community of other developers inside and outside of Microsoft that can help nudge you and get you past these sorts of problems. These people write blog posts, they answer questions in the various forums, they write books, they record screencast video tutorials like this one. And you can tap into that community of knowledge at any time. But let me give you a few tips on how to utilize that community in the most effective way. So let's suppose that you do hit a wall. You're experiencing some issue with your application. It's not behaving the way that you expected. Maybe you're getting some strange error message popping up every time that you try to debug your application. So where do you start to debug this, to pick apart the problem and get to the root issue? Well, first of all, I research using key phrases directly from the error message itself, and I can't emphasize how vitally important that is. So if there's an error number or a specific phrase that I can latch onto, and I can surround those in double quotes as I type in my query to bing.com, that always helps me get closer to a resolution. I might spend 10 to 15 minutes scanning through various blogs and forum posts or on MSDN as search results pop up for these sources in order to find a potential solution. And if I'm mindful about my search terms, I almost always find a solution. I think the reason why a lot of beginners fail with finding solution to their problems is because they become impatient, or they don't use they don't use the exact error messages in their searches, and they don't know how to search correctly, and they're not willing to put in the time to actually read through pages and pages of content to find a solution to the problem. So I can't emphasize enough, using the exact phrase inside the error message that you see on screen, surrounded with double quotes, will get you closer to finding a resolution to the issue that you're having. There are always usually people with other similar issues that have posted, and then explain what they did to actually solve that particular issue. So research is vital. And I think actually one vital skill as a modern software developer is to become great at search. Searching on the internet to help solve issues that you run into is such a vital skill. Now, it might seem easier to go directly to the forums immediately and to post a question to the forums in hopes that somebody else can help solve your problem for you. But I assure you that it will actually take longer to ask the question and get an answer than it would if you spent the time searching, refining your searches, and so on until you find a solution to your problem. Frankly, I almost never have to ask a question in the forums, because a simple search will almost always yield a clue to what I did wrong or what the core issue is. In fact, I've kind of gotten embarrassed when I have to ask questions. Maybe that's a bad attitude to have, but I don't want to burden other people with when they could be answering other legitimate questions. So I go overboard and try to figure out the issue on my own. Now, virtually any issue that you run into, I'm almost positive that somebody else has at some point run into that issue before you have, and they've already posted the solution to that problem online. You just need to get out there and find it. And if you get good at doing research, doing searches on the internet to help find solution to your problems, then it'll get you back on your feet faster than, again, posting into a forum and asking other people for help. Now, let's suppose that you're at your wit's end and you've done searches and there's nothing out there that really seems to apply to your situation. Okay, nothing you've tried actually works to resolve your problem. Maybe at that point you need to ask for help. That's fine. So here's what you really need to do to get, whenever you ask for help, you need to ask your question in such a way that you're going to get a resolution. And how you ask your question is important. So first of all, you need to be an empathetic requester. In other words, you need to give people who are willing to help all the information they need to actually get you back on your feet again, to pinpoint the issue and then isolate the issue and prescribe a solution. This means that you need to, first of all, clearly state your request. And so there's kind of a checklist that I have in my mind of the things that you need to do. And some of these will be obvious, and some of them you may have not considered before, so let me just go through them real quick here. First of all, you should start by posting your question in the right place. Find the right category in the given forum, or use the correct tags for your post, and so that the right people are looking at your questions. Posting a C# question in a Visual Basic form is not going to be all that productive. In fact, you'll probably get chided for it. Secondly, you also need to choose a simple, clear title for your post so that it attracts attention of the people who can help, so that it saves everybody a lot of time. If I see a forum post that just says, please help, I usually just skip it. If it says, link to objects queries yielding unexpected results, well, okay, that's oddly specific. That might be something I can help with. I look like the person put some effort into concisely stating what the issue is. So I'll read the question and I'll see if I can help. Third, a short synopsis of the issues that you're having, including the exact error message, including the exact behavior you are expecting and what you're actually experiencing. Describe what you expected to happen, but what it happened instead, and keep it concise. Fourth, if you can, at all possible, include screenshots. And ideally, you would go one step further and actually use some screen editing or image editing software and draw circles to draw the eye's attention to those parts of the screenshot that are pertinent to your question. All right. Fifth, if possible, include a code example. Make sure to change any super secret information, passwords, things of that nature before you post it. But without a code snippet, many problems are insolvable. Okay, I can't tell you how many times I get people writing me emails and they'll say, "I'm having a problem with this. What do you think the solution is?" I'm like, well, show me some code, okay? I need to see what you did to get to that point, and then maybe I can help you figure out what your issue is. So always include, if you can, a code snippet of the code that you think is causing the problem. Then be choosy about which code that you actually choose to post. There's nothing more frustrating than looking at somebody who posts like 200 lines of code and expecting me to go through it all when a lot of it doesn't even pertain to the question at hand. I mean, you had to spend a little bit of time narrowing it down to a few things, right? So you really need to help me, be empathetic to me, the person who's willing to help you, to identify those lines of code that might be involved in the issue. Number 6, if a given forum has special HTML tags or short codes that you can use to format the code or some other aspect of your question to help it stand out in the post, then you definitely should use it. All right. Number 7, tell me, what have you done so far to try to resolve the issue? Did it change anything at all? Did it change anything? Did it help? Did this lead you to rule out certain possibilities? Again, empathize with me, the person who's reading your question, trying to help you. This will result in a faster resolution. Otherwise, people will start with the obvious issues and then move forward. So there's just that old joke, you know, hey, I'm having a problem with my computer, and the technician asks, well, do you have it plugged in? Everybody says, oh, the technician, what? But there's a reason why they do that, and it's because the most obvious answer is the one that most of the time works for people. All right, so don't be that guy. Make sure you already list out what it is that you try to do and you've eliminated as a possibility. And so number 8, tell me which operating system you're using, which version of Visual Studio and the .NET framework, which programming language you're using, which updates, service packs have been applied, anything that you feel is pertinent to help you diagnose the issue. That matters more than you might realize. Number 9, suppose that there's a resolution to the issue. You actually figured it out. Awesome. Very cool. Maybe somebody made some suggestions that led you down to investigate some things and you finally figured it out. That's great. So take a moment, go back wherever you asked the question and describe exactly what you did to resolve the issue step by step. Use that as a means of better understanding it yourself, and articulating that will help you better understand the issue and what the solutions are. And then it's also, it makes you part of the community of the wealth of information that's out there, so that others in the future who have the same issue can look at your post and that you are feeding it back into the community just like you're taking out of the community. So chances are that, honestly, that person that you help in the future is actually you. I can't tell you how many times that I've found a resolution to something, and then months later I hit up against the same thing thinking to myself, I know I've solved this once, and I'll go searching for a solution and I'll find the exact solution and I'll rate it, oh, that was me. That was me who answered the question. So it would be nice just to search for your own solution online if you knew where it was, or at least find your, be courtesy to everyone else and to your future self to actually post answers to the questions that you have. All right, and then finally, absolutely, 100%, be polite. People don't owe you an answer. They don't owe you anything. If they're going to help you, they're going to do it out of the kindness of their hearts. They're going to be doing it in their spare time as a means of maybe, furthering their own understanding, helping themselves grow, but then also to help you grow as a software developer. So say please and thank you and be nice, and then help other developers as you have the opportunity. I do sell training content, but I give a lot of it away for free. I do ask questions in the forums, but I answer a bunch too. So make sure that you become part of that community and that you are feeding back into the community your own help and your support, just like you've been supported by others. All right. So you might be wondering, where do you go to find this level of support where you can ask questions? And that really depends. Typically, I'd recommend that you go to msdn.microsoft.com. Here, let's go out there real quick. So msdn.microsoft.com/forums, and it might redirect you based on where you are in the world. But typically, you can choose from a number of different forums, so you definitely want to find the specific technology or language or whatever the case might be, or do a quick search for those keywords, again, right here inside of the MSDN forums. It is monitored by Microsoft employees, as well as people called Microsoft Most Valuable Professionals, or MVPs. So MVPs are usually knowledgeable people who've demonstrated their willingness to help, and they've been identified by Microsoft as people who are willing to help, and so they qualify for that based on some criteria, not the least of which is participation in these forums. Then there's also another more comprehensive place you can take a look. Stack Exchange, so programmers.stackexchange.com. And there might be one other place where you could go that has, also by the same company, that has similar forums, depending on the type of information you're looking for. Now, in my experience, Stack Exchange is a little bit more iffy. It's a little less beginner friendly. Maybe that's changed by the time that you visit, and I only say that it's a little less friendly because not only will you be critiqued for how you ask your question, but very often if people do a search to help you and then they find that there's already an existing question that's similar enough to you, they'll shut your question down. So, just follow their rules, do an extensive search before you ask a duplicate question. Don't take offense to criticism about your question. And again, I'd recommend that you search long and hard before actually posting the question, because again, I'm convinced that virtually everything that you could run into has been asked by somebody already. You just need to spend the time to find that answer that you're looking for. All right, so I said that I would answer the question of where to go from here in two different ways, and I've answered the question where to go whenever you have problems, but now I want to answer the question, where do I go to learn more about application development? Where do I go to learn more about software development? And so at this point, you've got a pretty good foundation of C#, basic knowledge of the C# programming language and of .NET and a little bit about Visual Studio, but there's still a lot of opportunity to practice what you know and to grow beyond that. So no matter what type of application that you want to build, there are a few fundamental ideas that are really going to be, that you need to be fundamentally acquainted with before you move on. So first of all, I would recommend that you learn about relational databases like SQL Server. You learn how to access data that's stored in a database using the Entity Framework, part of the .NET API for accessing data in your applications. Both SQL Server and the Entity Framework have visual tools that you can use inside of Visual Studio to drag and drop and configure your settings and selections. And so spending some time not only learning about the tools and the APIs themselves, but then also these visual tools inside of Visual Studio can pay big dividends. You'll want to quickly grow past that and learn how to write code and rely less on the visual designers and Visual Studio, but still, it's a great tool to help you get to that point where you can be productive quickly. Next, you're going to need to choose a presentation technology that you want to master, and this is really more about platform, honestly, than just simple UI. So you have no lack of options, whether you want to build web or Windows applications or mobile applications or games or back-end processes, whatever the case might be. So say, for example, you want to build web applications. There's a couple of different platforms. The older API is called ASP.NET Web Forms, and there's a lot of code that was written on the Web Forms platform API. But then there's also a newer API that's called ASP.NET Core MVC, and there are some huge differences between the two, but we don't have enough time to talk about those. I have content on both of those topics on my own website, DevU. There's Windows Forms, which is the older desktop API. Then there's Windows Presentation Foundation, which is a newer API that companies use for building applications internally. And then there's the Universal Windows Platform, which you use to build more consumer-oriented applications, typically for sale on the Windows Store. There's also the Xamarin Platform, which Microsoft recently purchased at the time I'm recording this, for building true cross-platform apps for iOS and Android and even Windows Phone. And then there's a third party called Unity, Unity 3D or 2D, depending on the type of game that you want to build. And so you might want to check out Unity for building games. Now, if you're not really sure about where you should go next and what you should learn next, I really would recommend that if you don't already know HTML5, CSS3, and JavaScript, that's a great place to start. And I've created several fundamental series on Channel 9 that are aimed at each of these topics. They're also available here on Microsoft Virtual Academy, again, at the time when I recorded this. And then beyond that, I recommend learning about the basic tenets of application architecture, particularly how to structure your code into layers of responsibility and what that even means. So splitting your code into layers of responsibility will help you build applications that can withstand the impact of change. And like I said earlier in this series, change comes from a number of different places. It could be changing business rules. It could be changing requirements, changes in the technology that's available. It also comes from defects in your software, bug reports that come in, and you need to make changes to fix those. But in each case, you can mitigate the impact, the negative impact of making changes in your code by encapsulating the responsibilities behind well-established APIs between each of the layers of responsibility. And I spend a lot of time talking about this, about application architecture on DevU. So if that's something that interests you, you definitely want to check that out. But from there, you want to learn more about the basic software design patterns and tactics and techniques. And there are a few keywords that you're going to want to learn about. And each of these can spawn an entire book, an entire video series. And I've already alluded to the topic of object-oriented programming. That's a huge topic that you definitely want to learn about first. And if you can just get your mind wrapped around object-oriented programming and how that changes the way that you create solutions to programming problems, then that's a huge step in the right direction. But beyond that, you're going to want to learn about the principles of software development, principles that guide you to write your code in a very object-oriented sort of way. There are some more generalized principles like the DRY principle. I don't know that I've ever given it a name, but it's essentially don't repeat yourself. So, you know, I said be leery of copying and pasting, and when you do find yourself wanting to copy and paste code into multiple places in your application, you should be stopping yourself and thinking, how can I create this in such a way that I can reuse it? So don't repeat yourself. Put code, extract it out that will be reused into its own method or class, and then reuse it from there. There's also another principle called YAGNI, or YAGNI, which is you ain't gonna need it, which means, yeah, you could probably set yourself up and architect your application in such a way that in the future you could expand, but you're probably not going to need to do that. You ain't going to need it. All right. Then there's another principle or idea called dependency injection, which is super important. It's a design pattern that guides you towards building loosely coupled objects that then can be swapped in and out of the solution, and you'll want to learn about dependency injection. It's really crucial to building some of the new style applications using like the ASP.NET Core MVC, which relies heavily on dependency injection. There's also a set of principles called SOLID, S-O-L-I-D. Each of those stand for a different sub-principle. They help you realize the promise of object-oriented programming inside of your applications. So again, a lot of ideas that are more conceptual in nature and less code syntax or tool oriented. All right. You're also going to want to learn about the process of software development, so the workflow surrounding software development and managing software projects. So specifically, you're going to want to learn about the tools and the techniques that you use whenever you work inside of a team. Sharing source code between team members using a source code repository like Git, or like Visual Studio Online's implementation of Git and their own internal source code repository tool. You're definitely going to want to learn about building unit tests, which are tiny little code-based tests that continually are testing your code every time you run it. Some people have even gone as far to say that you should be writing those little unit tests first, and then you write the actual production code that satisfies those unit tests. Now, whenever there's a change made in the system, you can see what the impact of that change is, because you'll begin to see these little tests start failing. That is a process called test-driven development, and some people swear by it, other people swear at it. So you're also going to want to learn about agile project management, agile software development techniques, defining requirements in user stories, playing a game called Planning Poker to determine what features can we include in a given iteration of our software building process, using agile boards to manage assigned tasks between the various software developers on the team. You're going to want to learn about the nature of iterative development. I already used that term, iteration. So you want to learn about what are iterations and what are the goals of iterations and why they're useful. You'll want to learn about developing a spike of functionality all the way through all the layers of responsibility in your system. So I've given you probably, several dozen different key terms that you could use as a launching point to search on. And honestly, if you were to look at all those terms that I just used, it'll take you several years to learn about all those things, even at a very general, in a general way. But fortunately, again, you don't have to know it all to get started and be productive today. So yeah, there's so much to learn in so little time, but it's what makes software development fun and makes it exciting, because there's always something new to learn and some new technique to try. I've had friends at Microsoft actually confide in me that it's a challenge for them to keep up with it all. Nobody just knows all this stuff automatically. It's a challenge for everybody to keep up with. Nobody just knows it all. It just keeps evolving, and so you just have to really commit yourself to learning. I realized some time ago that my full-time job is not creating video content or training content for developers. My full-time job is really learning. And then if I create training content, that's really a byproduct of all the learning that I'm doing. The value that I have to somebody else is my knowledge. And so without that as kind of the core piece of what I do, whether it's building applications for somebody or creating training content, they're only interested in me because of my knowledge. And then how I apply that knowledge is a byproduct of actually gaining the knowledge. So you have to really commit to learning. And I know since you're here on Microsoft Virtual Academy that you've already done that to some degree. There's a bunch of great resources out that are available on the internet, not the least of which are Channel 9 and Microsoft Virtual Academy, obviously. There's MSDN, as we looked at earlier in this series. However, before I close this out, let me make one final plug for you to visit my website. If you haven't already, Developer University at devu.com. It's there on screen. I've designed the courses there specifically for someone who's a beginner, to help them get up and running as quickly as possible, pointing out what I feel like they really need to know in order to master key ideas that will lead them to get jobs in the software development industry, providing homework exercises and quizzes, but more importantly, coding challenges that force people to write and to develop the muscles of your mind that allow you to pick apart a problem and create a solution for it. All right. So please check check out devu.com whenever you get a chance. All right. So as I close here, I hope you found this course to be valuable and this lesson to be valuable. If there's anything that I can ever do to help you, please let me know. You can find me out on Twitter. I sometimes go out there. Hit me up on Facebook, or you can write me an email. But finally, as we close out, I sincerely wish you the best of luck in your career. C# and software development is such an exciting field to be a part of, and I'm really excited for you. So good luck. Thank you for watching this series.